Good morning, students. Today, let us discuss first the DPP 12 given as yesterday's homework, right? So, after that, we will go to continue with mole concept basics, right? So, let us discuss first question, which of the following is not a unit of pressure, right? Which is not a unit of pressure. This type of terms not incorrect, then not true, like that they will be asking, right? Not true directly they can ask as wrong answer, but they don't ask it as a identify the wrong answer. They will intentionally ask it as find which is not true, not correct, right? In that manner. So, you have to understand with this dangerous word. Okay. So, which is not the unit of pressure? We know we have discussed all the units of pressure, right? So, atmosphere, torr, dyne per centimeter square. All these three are units of pressure, but joule is not the unit of pressure. Joule is the unit of energy. Therefore, option D is the one which is the correct answer here. Then, which of the following interconversion is wrong? Interconversion is wrong. These interconversions also we have discussed in the yesterday's class. Let's say 1 atmosphere, 1 ATM is equal to 760 mm of Hg. This is correct. 1 atmosphere is equal to 760 torr is also correct. The reason is that 1 mm of Hg is equal to 1 torr. This already we have discussed, right? So, therefore, 760 mm of Hg can be nothing but 760 torr. Then next is 1 atmosphere is 1.013 into 10 to the power of 5 Newton per meter square. Newton per meter square. This is also correct. Whereas 1 atmosphere is equal to 1.013 into 10 to the power of 6 pascals is wrong. Therefore, this is the answer. This is a wrong interconversion. So, 1 atmosphere is equal to 1.013 into 10 to the power of 5 Newton per meter square. Na? So, this Newton per meter square, 1 Newton per meter square is 1 Pascal, right? So, as we know, as 1 Newton per meter square is equal to 1 Pascal. 1 Pascal, it can be written as 1 ATM is equal to 1.013 into 10 to the power of 5 Pascals. 10 to the power of 5 Pascals, but he has given it as 10 to the power of 6 Pascals. That is the mistake, right? So, going to the next point, next question, which of the following is not a unit of energy? Which is not the unit of energy here? Calorie is the unit of energy, we know. Joule is also unit of energy, we know. Then Newton meter is also unit of energy, whereas a Pascal is the unit of pressure, right? So, this is the answer. Then 1 joule is equal to, I have given you one shortcut, that is 1 calorie is or interconversion to say 1 calorie is equal to 4.18 joules. Then 1 joule will be equal to this, to come on this side, that it will become 1 by 4.18 calories. So, if you calculate 1 by 4.18, you will be getting, you will not get this one, you will not get this one, you will not get this one, you will be getting this. 1 by 4 is nothing but 0.25. So, very nearer to 0.25. So, 0.239 calories. So, in this manner, you can identify. So, 1 calorie is equal, just now before only we have discussed this one, 4.18 joules, right? Next, which of the following is a unit of energy? Unit of energy. Unit of energy. Pascal is not the unit of energy. Newton is not the unit of energy. Dyne is not the unit of energy. Kg meter square second to the power of -2 can be the dimension or unit of energy. So, this is correct. Kg meter square second to the power of -2. Okay. The next, 1 liter is equal to 100 ml, no, 1000 ml it is 100 centimeter cube. Ml is what? Centimeter cube. So 100 ml is wrong, then 100 centimeter cube is also wrong. And 1 decimeter cube is actually correct, and 1 meter cube. 1 liter is equal to 10 to the power of minus 3 meter cube, right? 1 liter is equal to 10 to the power of minus 3 meter cube, right? And 1 liter is equal to 1 decimeter cube. This is what he is asking. So this is the correct answer, right? All these interconversions are important. 1 meter cube, that is what just before I have told you. 1 meter cube is equal to 1000 liters. And we know 1000 liter means 10 to the power of 3 liters. And we know as 1 liter is equal to 10 to the power of 3 ml. So if you substitute it as a 10 to the power of 3 ml, already 10 to the power of 3 is there, into this 10 to the power of 3 ml, altogether it will come to 10 to the power of 6 ml. 10 to the power of 6 ml. So first option itself is correct. Then coming to 0 degrees Fahrenheit is equal to 0 degrees Kelvin or 0 degrees Celsius. I have told you one interconversion factor here. Degree Fahrenheit is equal to degree Celsius into 9/5 plus 32. This is the interconversion relation between Fahrenheit and Celsius scale, right? Degree Celsius. So where is it present? This is degree Celsius into 9/5 plus 32. This is the correct answer. Okay. Next, 1 kilowatt hour is equal to 3.6 into 10 to the power of 6 joules. This is the direct value. You have to remember this one. 1 kilowatt hour is equal to 3.6 into 10 to the power of 6 joules. 10 to the power of 6 joules. Remember this one. So it will be useful in your calculations also. Kilowatt hour is the unit of energy only, right? The next, 1 joule is equal to, this already we have discussed, 1 joule is 10 to the power of 7 ergs. Very easy questions, all these are very direct, right? Pressure is force per unit area, correct. Force per unit volume, wrong. Force per unit length, wrong. None of this is also wrong because there is an answer. Next, 1 Newton meter is equal to 1 Newton meter. Actually, Newton meter is something like SI unit and for energy. So, Newton meter is nothing but joule. 1 Newton meter is nothing but 1 joule. The next, 1520 mm of Hg is equal to how many ATM? We know that 760 mm of Hg is 760 mm of Hg is 1 ATM. Then 1520 mm of Hg will be how much? 1520 mm of Hg will be how much? So this you have to do the cross multiplication. 1520 into 1 divided by 760. So this goes 2 times. So this is a 2 ATM. 2 ATM. Right now? So next. 12.561 joules is equal to how many calories? We know 4.18 joules is equal to 1 calorie. Then 12.561 joules will be equal to how much? So just you need to cross multiply again. 12.561 into 1 divided by 4.18. So 4, 3, roughly it is coming to 4.2 if you consider. If you consider it as a 4.2 and you can assume it as a 12.6. So 3 times it will go, right? So 3 calories will be the answer. 3 calories, okay? Which of the following? Did we tick mark answer? No. 3 calories. Which of the following statements about basic physical parameters is incorrect? For some of the physical parameter, it is given incorrect, so that we have to recognize it. Density is defined as mass per unit volume. So density is, we know it is mass by volume. So mass per unit volume, that is correct. Density is defined as mass per unit volume, is correct. Temperature is a measure of total kinetic energy of a substance. Temperature is a measure of total kinetic energy of a substance. No, temperature is a measure of hotness or coldness of a body. So this is wrong. He is also asking wrong statement only. Pressure is the force exerted per unit area. This is also correct. The SI unit of energy is joule. This is also correct. So second statement is a wrong statement here, right? So going to the next question. Match the following. Match the physical parameters with their corresponding SI units. There are physical parameters in column 1 and their corresponding units are given. Just you have to match them. Pressure. Joule, no, Pascal. So 1B. 1B. Energy, joule, is correct. 2A. What about 3 and what about 4? We have to see. 3 is density, right? Density is kilogram per cubic meter. Kilogram per cubic meter can be taken, right? Because it is mass per volume. So that is correct. And temperature unit can be Kelvin. This is also correct. D. So B, A, C, D. B, A, C, D. This is only correct answer. This is a C, B, D, A. This is D, C, A, B. A, D, B, C. So all these are wrong. Going to next question. Which of the following statements about fundamental units is incorrect? Again he is asking incorrect statement. Incorrect statement. The SI unit of mass is a kilogram. The SI unit of mass is a kilogram, correct? The SI unit of time is a second, also correct. The SI unit of electric current is ampere, that is also correct. The SI unit of volume is a cubic centimeter. Cubic centimeter. I think in your material it is typed as a cubic meter. With respect to your material I am telling, right? So it is given in your material as a cubic meter, but in brackets given as a centimeter cube. Cubic meter up to here, this is correct. But in brackets, whatever centimeter cube is given, that is wrong. That is wrong. Okay, na? Or even if you consider it like this, as it was centimeter cube, I also mentioned here in PPT also as cubic centimeter, right? So either it is mentioned as in your material or in the PPT, in this presentation, both are wrong only. So finally, the answer in whatever way it is given, that is wrong only here. The correct will be only when it is given as the SI unit of volume is a cubic meter in brackets like this. Then only this will be correct. Cubic meter in brackets M3, M cube. Okay, na? Next. Which of the following statements are true or false? That means just 4 statements are given. You have to recognize which of them is true, which of them is false. Right? Na? So first one is the SI unit of force is Newton. SI unit of force is Newton. Correct? Na? First one is correct. The SI unit of energy is joule. That is also correct. The SI unit of pressure is Pascal. That is also correct. The SI unit of frequency is watt. The SI unit of frequency is watt. Just it is okay. So SI unit of frequency is watt. This is wrong. Okay. So fourth statement is wrong. SI unit of frequency is not watt. SI unit of frequency is time inverse or second inverse. Frequency is frequency unit is time inverse, or in particularly as an SI unit it is second inverse. So three statements are true. This is true. Oh, that we have already written earlier. That is why it will not go now. Anyway, luckily answer also will come to this only. So first is true, second is true, third is also true, fourth is wrong. Okay. True, 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 false. So this one is correct. True, 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 false. Okay. Then going to next question. The last question of this DBP 12 is which of the following fundamental units is incorrectly matched? Which of the following fundamental units is incorrectly matched? Incorrectly matched. Length, meter, correct. Time, second, correct. Luminous intensity, joule, wrong. Electric current, ampere, correct. Right? Luminous intensity unit is a candela. Candela. But he has given it as joule. Energy unit is given. Right? So that is wrong here. So in this manner you can understand you can understand the PPT, the DPP 12 discussion is completed with this. Now let's get into basics of mole concept. So hope you have understood yesterday's concept what we have discussed, that is a relative atomic mass, relative molecular mass, then atomic mass unit, then atomic mass, then molecular mass, then mole, then gram atomic mass, then gram molecular mass. So total 8 terms with their definitions we have discussed yesterday. 8 terms we have discussed along with their definitions, examples, conversions, etc. Right? All these 8 terms are very, 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 very important. Right? Now? So now let's get into our topic now. Y map. Y map or Y diagram to say. So this is a Y map or Y diagram. Actually there is one concept here that is we are relating mole with a volume, mole with a mass, mole with number. So 4 terms we are taking here. 4 terms we are taking here. Y map, or this is the way we want to represent is like this. Y map. Okay, na? So we want to relate mole with a volume, mole with mass, mole with number. So first point, understand what is the need of this Y map. This is what the Y map you will be getting. If you join this and then join like this, you will be getting Y map or Y diagram. So what is the need of this Y diagram is the data in our question can be given in any of these 4 forms. The data in our question can be given in any one of these 4 forms. Let us assume that the data is given in volume and he is asking in a number of moles. So you should understand how to convert volume to mole or mole to volume. Or else let us assume that the data is given in volume and he is asking in terms of mass. Then what you need to do, you first whatever the data is given in volume, should be converted into moles. From there you can convert it into mass. So in this manner, whenever interconversion is required, that interconversion you can do through the junction, that is a mole concept. Mole concept. So whatever the data, in whatever manner it is given, either it is given in the form of volume or mass or number of particles, all can be converted into mole, or mole can be converted into any of the data, any of the values. Okay. So let us keep it as it is. First of all, let us discuss what is this volume we are talking about. Volume, right? So in last topic also we have discussed what is a volume. It's not about that point here. What we will be discussing here is if you know, might be some of you have heard of ideal gases. Have you heard of ideal gases? Ideal gases? Gases, whatever the gases we are having in reality, in our atmosphere, they are all real gases. And whatever the gases, assumption, whatever the assumed gases are there, which will follow the gas laws, that is Boyle's law, Charles' law, Avogadro's law, Gay-Lussac's law, etc. So they are what the ideal gases. But in reality, when you apply these gas laws to the normally occurring, really occurring gases, they are not perfectly following these laws, right? So in two ways you can classify the gases. One is ideal gases, which will follow the gas laws, and another one is real gases, which are actually the gases which are existing in our atmosphere. But for time being, this all discussion, what are ideal gases, what are the properties, and then real gases, how to do a correction to make the gas laws applicable to real gases, that all will be discussed in a future chapter, that is the states of matter. But right now what you have to understand is, whatever the gas is given to our level, for time being, what you have to understand, remember, is whatever gas is given, you have to assume that that is an ideal gas. Assume that it is an ideal gas. Suppose he is talking about some hydrogen gas is given, or oxygen gas is given, or any other methane gas is given, whatever gas is given. So you should assume that that gas is an ideal gas. Ideal gas. Understanding? Na? So what the concept is, any 1 mole of an ideal gas at STP conditions have a volume of have a volume of 22.4 liters. This is the point. 1 mole of an ideal gas at STP conditions will be occupying a volume of 22.4 liters. First of all, 1 mole we already know, that is the Avogadro number, 6.023 into 10 to the power of 23 gas atoms or gas molecules. So when 1 mole of gas is taken, in what conditions of pressure, temperature, volume, right? There are 4 parameters actually which will fix the gas, right? So that is pressure, temperature, volume, and number of moles. N is the number of moles. Number of moles I have already fixed it. Okay. Now these 3 are there. Within these 3, STP conditions is nothing but a standard. I think some of you might have studied also in CBC 10 standard conditions. According to these standard conditions, the standard temperature is 0 degrees Celsius or 273 Kelvin, right? Standard pressure is 1 atmosphere, right? Right now it is 1 bar, but we are going with respect to 1 atmosphere for this calculation, right? So if you take 1 atmosphere, you should consider 22.4 liters. If you take 1 bar, which is the latest one, but still 1 atmosphere is only followed in our books. If at all, if you take 1 bar, it will not be 22.4, it will be 22.7. So this is one point you have to understand here. So for time being, in our CBC discussion, we are considering it as 1 atmosphere. Therefore, it will be 22.4 liters. So the standard volume will become, you have fixed N, you have fixed pressure, you have fixed temperature, therefore automatically volume also gets fixed. Among the 4 parameters, 3 of the parameters, if you fix them, automatically the 4th parameter also will fix. That fixed value itself is 22.4 liters. 22.4 liters. Okay, na? So in this manner, these are the standard conditions of temperature and pressure that we are following, right? So now, understand that 1 mole of an ideal gas at STP conditions has a volume of 22.4 liters. Suppose if I take at STP 1 mole gas will occupy 22.4 liters. What about 2 moles? 2 moles will occupy how much? 44.8 liters, na? What about 11.2 liters? Suppose if any gas is having 11.2 liters at STP, then how many moles it is given? You can understand that it is of only 0.5 moles. So in this manner, at STP, you can link between mole and volume. 1 mole is 22.4 liters. 1 mole of gas will have a volume of 22.4 liters. Right now? So the same point, if I go back, this is 1 second. Now, if I consider volume with I will erase and write it bigger, okay na? So little I will take it to the center. Mole volume of ideal gas at STP, then mass, then number. Okay. So mole, if I want to link it with a volume, then how I have to write it as? Mole, if I want to link it with a volume, how I should write it as? As already I told you, if you are having 1 mole, can you convert 1 mole to volume? 22.4 liters, right? 2 moles, what will you do? 22.4 into 2 you will do, na? And 3 moles, 22.4 into 3 moles you will do. That means, to the number of moles, if you multiply with 22.4, you will be getting the total volume. To the number of moles, if you multiply with 22.4, you will be getting the total volume. So this is into 22.4. This direction of arrow, right na? And what about this direction of arrow? Volume to mole. 22.4 liters is 1 mole, or else we will 22.4 liters is 1 mole. 44.8 liters is 44.8 divided by 22.4. That becomes 2 moles, right? 2 mole. If it is 11.2 liters is given, then what do you do? 11.2 liters, 11.2 divided by 22.4 you will do, that you will be getting it as 0.5 moles, right? So that means volume, if you want to convert into moles, what you need to do? Volume will be divided by the given volume. The given volume will be divided by 22.4 liters. This is also you can understand 22.4 liters is 1 mole is because given volume is 22.4 liters divided by 22.4. So this cancels and becomes 1 mole. So volume, if you want to convert into number of moles, you should divide it by 22.4. So understood this interconversion? Mole to volume, then volume to mole. So this is the first point. Then second point is, if you want, you can write also this concept, right? Second point is, how can you convert mole to mass? And then mass to moles. Mass to moles. So this is also an easy concept. That is, if I go to now let's see, mass mole relation, right? Na? This was, the earlier one was this only, mole volume relation. Okay. Now mass mole relation, as everybody knows, mass of 1 mole of any substance is equal to its gram atomic mass. In the last lecture we have discussed mass of 1 mole of any substance. If that substance is existing in atomic state, it is gram atomic mass. If it is existing in a molecular state, then gram molecular mass, right? So mass of 1 mole of any substance is GAM or GMM. So now mass of 1 mole, mass of 1 mole, how much it will be? GAM है ना, or else we write it like this. See, let us take the example and then discuss. Let me take a carbon only, C12 only I will take. 12 grams carbon 12 is equal to how many moles? That is 12 grams given mass divided by GAM. GAM of that is 12 grams divided by 12 grams. GAM of C12 is 12 grams only. So 12 will get cancelled, that it will become 1 mole, right? Then 24 grams is equal to, given is 24 grams divided by gram atomic mass will become 2 mole. That means mass, mass, how you are converting into mole? By dividing with gram atomic mass or gram molecular mass, right? Mass divided by GAM or GMM will give mole, and reverse, if moles are given, right, like 1 mole, is equal to 12 grams. How you got it? 1 mole into GAM. 1 into GAM. GAM is 12 grams. So 1 into 12 grams is 12 grams mass. 12 grams mass. Right? Then 2 moles is 2 moles into 12. So 2 into 12, 24 grams. 0.5 moles is into 12. 0.5 into 12 is 6 grams. So how you are converting mole to mass is by multiplying with gram atomic mass, right? So this is mass divided by gram atomic mass is mole. Mole into gram atomic mass is mass. Understanding? So this is one thing. So first point, see, mass to mole to mass. Mole into gram atomic mass. Mole to mass. Mole into gram atomic mass or gram molecular mass. Whether you should use gram atomic mass or gram molecular mass, that depends upon in what state that substance is existing. Is it existing in atomic state like helium, neon, argon, krypton, iron, copper, etc.? Or is it existing in a molecular state like H2, O2, CO2, SO2, CH4, etc., methane, etc.? Understanding? And mole to mass is multiplied by gram atomic mass. If you want to convert mass to mole, it should be divided by GAM or GMM. Understood this one? So in this manner, you can do the interconversion here. And coming to number by this you might have already understood what we are doing, how to convert mole to number and number to mole, right? So what is the difference here is, or else let us discuss also if you want, no problem. Mole number relation. Okay na? Mole number relation. Suppose if I am given 1 mole C12. What does it mean? 1 mole C12 means how many atoms it is? That is Na number of atoms, Avogadro number of atoms. 2 mole C12 means what? 2 Na atoms. That means what you are doing? To the number of moles, you are multiplying with Avogadro number. You are multiplying with Avogadro number. 10 moles means 10 into Na, that is 10 Na atoms. Right na? So this is one point. Mole on multiplying with Avogadro number, you will get total number of atoms. Mole on multiplying with Avogadro number, you will get total number of particles. Number of particles. What are that particles? They may be atoms, molecules, ions, electrons, protons, books, pens, bananas, whatever they are. Right? That many objects or articles or particles or what? Anything. Right? And what is the other point? Reverse. Reverse you can understand here, right? Number of particles divided by Avogadro number will give you number of moles. This is what is called as a Y diagram. Maybe in your material they are given in opposite directions, right? So that is not the point here. Concept is the one which you have to understand, which you have to learn how we got this Y diagram. And this is a very, very, very important concept in our not only mole concept chapter, for the entire physical chemistry concept. right? So we should clearly understand mole can be converted into any data. It can be converted to volume, mass, and also number of particles. In the similar way, any type of data, it may be given in terms of volume or mass of substance or number of particles. Any type of data can be converted into mole, and mole can be converted into any type of data. So depending on in what way they have the given data in the question, in what way they are asking it. Suppose they have given it in terms of volume, but they are asking mass. You should go through mole. You should take the help of mole. So with respect to the mole concept, we will be calculating what is the mass. Understanding in this manner. Now, let us take some questions here. Some examples here. Calculate the number of moles in the following. First one. 4 grams of H2 gas. B. 4 grams of H2 gas. B. Uh, 3 into 10 to the power of 23 sodium atoms. C. 5.6 liters of oxygen gas at STP. Like this 3 data are given. First of all, just we are understanding, trying to find out the data is given in different forms, that to convert it into number of moles as the first step. So 4 grams of a hydrogen gas. How do you convert mass? Grams means mass, na? Grams means mass. So the data is given in mass and he is asking to convert it into moles. How do you convert mass to moles? Just go back to Y diagram. Mass to moles, that is this one. Mass to moles. So mass can be converted into moles by dividing the mass, given mass, with gram atomic mass or gram molecular mass, right? This Y diagram you have to by heart. Here I am showing, but in exam it will not be given, right? We only have to calculate. Number of moles is equal to given mass divided by gram atomic mass. Gram molecular mass here, because it is H2 molecule. Gram molecular mass of hydrogen gas is 2. So 4 by 2, that is 2. 2 mole. 2 moles is given, right? Then second, 3 into 10 to the power of 23 sodium atoms. Atoms, it is given in terms of atoms, means particles, right? So when it is given in terms of particles, then number of moles will be, number of moles is equal to number of particles given, that is 3 into 10 to the power of 23 divided by Avogadro number, that is 6 into 10 to the power of 23. So this cancel, 3 ones are 3 twos are. So this is 1 by 2, that is half mole. Half mole is given. And now coming to 5.6 liters. Liters is what? Volume. So the data is given in volume. So 5.6 liters of oxygen gas at STP will be having how many moles? So number of moles is equal to volume given 5.6 liters divided by 5.6 liters divided by volume of any gas at STP conditions will follow, will have 22.4 liter. Liter will cancel. 5.6 ones, 5.6 fours. So this will become 0.25 mole. 0.25 mole. So in this manner, mass or number of particles or volume can be converted into moles. 2 moles, 0.5 moles, 0.25 moles. So in this manner, the conversion can be done. A reverse conversion also can be done, right? So that is, let us consider the another question. Do the necessary conversion. A. 1 mole of methane gas weighs dash grams. 1 mole of methane gas weighs dash grams. Then B. 2 moles of sodium metal has dash atoms. Then C. Half mole of oxygen gas at STP occupies dash volume, dash liters of volume. Dash liters of volume. So see here, the data is given in terms of moles and he is asking in different terms like mass, grams, then atoms, that is particles, then liters, that is volume. So reverse calculation we are doing here in comparison to the previous question, right? In a previous question, in different forms, different data we converted into number of moles. Now moles we are converting into different data. Understanding the point? So let's see here. 1 mole of methane gas. 1 mole of methane gas weighs how much, right? So mass of methane, what did we study here? Mass can be converted into, moles can be converted into mass by multiplying with gram atomic mass or gram molecular mass. Okay. So mass of methane is moles, number of moles into gram atomic mass or gram molecular mass. So how many moles of methane is given here? 1 mole, na? So 1 into methane is CH4, right? CH4 is a methane, that is a gram molecular mass. What is the gram molecular mass of methane? 12 grams plus 4 grams, total 16 grams. So 1 into 16 grams is equal to 16 grams. 16 grams. So 1 mole of methane weighs about 16 grams. 16 grams. Then second one, 2 moles of sodium metal has dash atoms, right? So number of particles, number of atoms is equal to number of moles into Avogadro number, right? So this is what we have discussed in the previous discussion. So number of sodium atoms is equal to number of moles. How many moles are given to us? 2 moles, na? So 2 into Avogadro number, that is 6 into 10 to the power of 23. This becomes 12 into 10 to the power of 23. I am making it as a rounding off, so that calculation will become easy. So depending upon the options given, we have to select which one will be the correct answer, matching answer. So here it is 12 into 10 to the power of 23. these many atoms of sodium are present in 2 moles of sodium metal, right, sample. Then 0.5 moles of oxygen gas at STP occupies how many liters volume? We know volume at STP is equal to given volume at STP is equal to number of moles into 22.4 liters, right, at STP. So, how many moles are given? 0.5 moles are given. So, this is a 0.5 into 22.4. This becomes 11.2 liters. So, this is 11.2 liters. So, in this manner, moles can be converted into different data also, either it is a mass or number of particles or volume. Understanding? Now, another interesting conversion let us see here, that is this is the question. 46 grams of sodium metal has a dash number of atoms. So, 46 grams is a mass and he is asking in number of particles. So, it is nothing but here, let us go to the first diagram. 46 grams mass is given and number of particles he is asking. So, this is what the link he is expecting us to find out. This is right, mass to be converted into number of particles here, right. But through moles, whatever mass is given, that should be first converted into moles, then that moles can be converted back into particles. So, in this manner he is asking in this point, right. So, first of all you calculate number of moles from 46. Number of moles is equal to 46 grams divided by 23 grams. 23 grams is the gram atomic mass. So, 2 moles. Then, now 1 mole, or else you already know this point, right. Directly also we can write now. So, now it is 2 moles. Ana? So, 2 moles number of particles will be, 2 moles number of particles will be number of atoms is equal to number of moles, 2 into Avogadro number, that is 6 into 10 to the power of 23. So, this becomes 12 into 10 to the power of 23. So, in this manner you can calculate from mass, we calculated number of particles, 12 into 10 to the power of 23. So, in this manner reverse calculation also can be done and can be made. Okay. So, this is all about Y diagram. We can take 1 or 2 questions from our sheet itself, as some of you are having the sheet. So, I will tell you the page number, you can see the question. Okay. DPP 13, if you go to DPP 13, try to calculate 11th question, DPP 13, 11th question, page number 67. Okay. So, 2 minutes, let us take the time and you try it once and then we will discuss. Okay. And this diagram you have to by heart it, you should memorize, remember it, this diagram. Okay, na? Page number 67, 11th question. Trying, right? Calculating, I hope. And very importantly, I think everybody is having the material. If anybody is still not having the material, you should immediately, quickly reach to your enrolled center, study center, campus, and get your material, right? And this is a must and should. Nobody should be sitting for the class without material, without the CBC material. Every day, whatever DPPs are given, that is mandatory to be solved. Okay? And that related questions also will be asked when you come back in the regular classes. Chalo. So, hope you have solved this one, and let's see. If you have not got the answer also, no worries. So, let's see. What is the question given? 11th question. First of all, I will read the question. The mass of one molecule of a compound, mass of one molecule is 1.66 into 10 to the power of minus 22 grams. Mass of one molecule is 1.66 into 10 to the power of minus 22 grams. Then what is the molecular weight? Molecular weight, right? Molecular weight. So, for molecular weight, first of all, what I will do is, first of all, I will calculate gram molecular weight. Gram molecular weight is the mass of Avogadro number of molecules. Mass of one molecule is 1.66 into 10 to the power of minus 22 grams. Then mass of Avogadro number of molecules will be this mass of one molecule into Avogadro number, that is a 6 into 10 to the power of 23. 6 into 10 to the power of 23, right? So, if we calculate this one, how much you will be getting? 36, 39, 6 ones are 6, 9, right? So, 996, that is a 9.96 into 10 to the power of minus 22 into 10 to the power of 23. So, if this is cancelling, this will come to 10 to the power of 1, right? 10 to the power of 1. So, 9.96 into 10 to the power of 1, that is 99.6 grams. 99.6 grams is the gram molecular weight, but he is asking molecular weight, right? So, molecular weight, therefore, molecular weight will be 99.6 AMU. 99.6 AMU. 99.6 to the round figure, it is given as 100. 100 AMU is the molecular weight. 100 grams is the gram molecular weight, GMM, or gram molecular mass. Understanding? So, in this manner, you can calculate. So, for tomorrow's class, DPP 13 will be the homework. right? So hope you have understood, you have enjoyed today's class. That is a Y map, very, very important concept for the entire physical chemistry. So revise it. If you are having any doubt, yesterday also I have given my number. 2-3 students have sent their doubt, right? So very beautifully you are practicing the questions. So if you are having any doubt, right, so you can message me in WhatsApp, so that we can send you the solution also, or any explanation required. Right? So practice DPP 13 for tomorrow's class, and next lecture is physics, that will start by 10:20 a.m. The next class physics will start by 10:20 a.m. So quickly take your break and come back on time, so that you will not miss any of the points in physics class, right? So thank you, all the best.
Good morning to all of you. Let us continue with the problems, whatever we were doing yesterday. A mass of 1 kilogram is suspended by a string. Another string C is connected to its lower end. If a sudden jerk is given to C, what will happen? It may be 1 kg, it may be 5 kg, it does not make any difference now. If you are giving sudden jerk, all of a sudden, force will not be conveyed to string A. So what will happen? Due to that force, only the lower string will break. So your first C string will break if you are giving a jerk. But if you pull it for a longer time, you apply the force, then what will happen? Force will be conveyed to string A. Then A will break. What do you mean by that? If you are giving a sudden jerk, C will break. If you are pulling it for a longer time, string A will break. So here, let us see the alternate. The portion AB of the string will break. Wrong. The portion BC of the string will break. None of the string will break. The mass will start rotating. The portion BC will break. Clear to you? Let us move to next question. In the above question, if the string C is stretched slowly, already I have told you. If you are applying force for a longer duration, you are pulling it, force will be conveyed to upper string, then upper string will break, and upper string is AB. So answer for this is, the portion AB will break. So this string will break. It means answer will be A. Let us move to next question. Define momentum. They want to ask you, define linear momentum, not angular momentum. Already we have learned it nicely. Mass times velocity, linear velocity, is known as linear momentum. So your linear momentum P, which is a vector quantity, this is P equal to mv. Direction of V and direction of P will be same. Means direction of linear momentum will be the direction of velocity vector. Magnitude will be mass times magnitude of velocity vector. Let us move to next. Define SI unit of linear momentum. Just now you have written P, if I take mod, this is mv. M, kilogram, this is meter per second. It will become kilogram meter per second. Sometimes we are also taking F equal to dp by dt. F is dp by dt. So dp will become F dt, F Newton, and dt in second. You will be considering Newton second. Let us move to next question. What is the momentum of a particle of mass? Mass they have given you 5 gram. This is 5 10 to the power minus 3 kilogram. Velocity they have given you 10 centimeter per second. 10 to the power minus 2 meter per second. Clear? Now, they are asking you linear momentum. Linear momentum mod, this is mv mod. So 5 10 to the power minus 3, 10 10 to the power minus 2. You will have kilogram meter per second. So this will become 50 into 10 to the power minus 5. So 50 into 10 to the power minus 5 is 5 10 to the power minus 4 kilogram meter per second. Answer 5 10 to the power minus 4 meter per second. Let us move to next question. We are on number 6 now. A particle of mass 2 kilogram moving with a velocity of 10 meter per second strikes a wall normally to it and rebound with the same speed of 10 meter per second. Identify the correct statement. So you have a wall and you have a particle. It is moving in this direction. Mass they have given you 2 kilogram. It is moving in this direction with velocity 10 meter per second. 10 meter per second. Right? And it is rebounding with the same speed. It is rebounding with the same speed 10 meter per second. Suppose if this direction is positive x direction, so this will be plus I, unit vector I am taking, so this will be minus I. Now, they are asking you the change in linear momentum. The change in linear momentum, whenever you are considering, you will have this side P del P will be P final minus P initial. P initial. P final will become minus 2 into 10, 20, and you are taking I, so I have kept minus 20, and this will become minus 20. So this will become minus 40 kilogram meter per second. Or you can say it 40 kilogram meter per second, direction is minus I with the assumptions whatever we have taken. Okay? Let us check A. The change in momentum is 0. Magnitude of change in momentum is 0. The change in magnitude of momentum is 0. All are correct. Identify the correct statement. I don't think so. A particle of mass 2 kilogram moving with a velocity of 10 meter per second strikes a wall normally to it and rebounding with the same speed. They're asking you change of linear momentum. The change of linear momentum, first magnitude. The magnitude in this direction is 2 into 10, 20. And returning with 2 into 10, 20. The change in linear momentum will be final linear momentum minus initial linear momentum. If you consider the direction, answer will become minus 20 minus 20 minus 40 kilogram meter per second. Means your answer is 40 kilogram meter per second is change of linear momentum in the direction in which ball has rebounded. Okay? And not a single answer is correct here. Let us move now to next question. A loaded transport truck with a mass of 38 ton is traveling at 1.20 meter per second. What will be velocity of 1200 kilogram car if it has same linear momentum? First, 1 ton. Actually, it is metric ton. 1 metric ton or 1 ton is 1000 kilogram. So you will have m1 38 into 10 to the power 3 kilogram. V1 1.20 meter per second. M2 is 1200 kilogram. And they are asking you velocity, means they are asking you V2. They have same linear momentum, means P is same. If magnitude is same, so this will be equal to M1 V1 is M2 V2. V2 will become M1 V1 by M2. M1 38 10 to the power 3 into 1.2 by 1200. Okay? If you are dividing 1.2, 1.2 into 10 to the power 3 will become 1200. So you will have 1.2, this will become 1000, this cancel, answer 38 meter per second. Clear to you? Simple. P you have to equate. M1 V1 must be equal to M2 V2. Now, move to next question. A particle is moving in a straight line with increasing speed. If particle will be moving along a straight line without return, then speed and velocity are equal. Now they are telling you its speed is going on increasing, means velocity is going on increasing. It means on the particle a force is acting along the direction of motion. When force is acting, it means particle has acceleration. Let us see what are the answers given. There is a net force in the direction of motion. Yes, there is a net force acting along the direction of motion. There is a net force opposite, the net force on the particle perpendicular, there is no net force. A itself is correct answer, net force acting along the direction. Because according to Newton's first law, velocity will be changed when a net external force will be acting on the particle, right? So, when net force will act along the direction of motion, then only particle will be accelerated. The answer is A. Let us move now to next question. A particle is moving in a straight line with decreasing speed. You have a particle, it is moving along a straight line, and if it is not returning, same again, speed and velocity will be same. And now they are telling you velocity is decreasing. The motion is retarded. For retarded motion, undoubtedly there would be a net external force acting on the particle opposite to the direction of motion. So here you say A, along the direction, B, there is a net force acting opposite to the direction of motion. Answer will be B. Check the answer. Your answer is B. Now, let us move to next question. A particle is moving in a curved path with constant speed. When a particle is moving on a curved path, instantaneously there must be a force acting at right angle to the direction of motion. You know, in uniform circular motion, a centripetal force is needed. Without centripetal force, particle cannot move in circular path. So here they are giving you there is a net force in the direction of motion, there is a net force opposite to the direction of motion, the net force on the particle is perpendicular to the direction of motion. There is no net force acting on the particle. The answer here will be the net force on the particle is perpendicular to direction of motion. Answer will be C. Let us move now to next question, number 11. Define the SI unit of force. I have taught you. Force is mass times acceleration. In SI, if you take F, F is ma, m kilogram, a 1 meter per second square. This is 1 Newton. The unit for force in SI is Newton. When 1 Newton force is acting on a particle of mass 1 kilogram, it will produce an acceleration of 1 meter per second square along that direction in which force has acted. The 1 Newton is that force which, when acts on a particle of mass 1 kilogram, produces an acceleration of 1 meter per second square along the line of action of force. Clear to you? Let us move to next question now. When an unbalanced force is applied to a body, then which quantity does not change? When you are applying unbalanced means there will be some net force acting on the particle. When net force will be acting on the particle, motion will be changed. Its velocity will be changed. There will be acceleration produced in the body. In Newtonian mechanics, only mass is considered to be constant. When velocity will be changed, its linear momentum will be changed. Okay, so answer here, which quantity does not change? Answer will be its mass. Clear to you? Now, let us move to next question. A force acts on an object which is free to move. Okay? The second law of motion enables us to determine the magnitude of force and the mass of the object if we know. Okay, no? Force is acting on an object. When force is acting, force equal to mass into acceleration. You are getting it from Newton's second law. And they are telling you, how will you find magnitude? You are knowing the magnitude of force. Okay, they are telling you, enable us to determine the magnitude of force and the mass of the object if we know its acceleration. If a force is acting and mass, if it is applied to you, you can find out. Okay, no? Mass, if you know the acceleration, F equal to m into a, m will be equal to F by a. Clear to you? So here, answer will be acceleration. Okay? So, next, let us move to next question. These are simple concept-based question is there. Newton's second law is qualitative, quantitative. When I was teaching you Newton's laws of motion, I told you. Newton's first law is giving you qualitative concept of force. What do you mean by qualitative concept? Qualitative concept means you are getting definition of force. It is not giving you the magnitude or quantitative concept of force. The second law is giving you quantitative measurement of force. You are deriving F equal to m into A from Newton's second law. So here your answer will be B, quantitative measurement of force. We are finding out from Newton's second law and we have derived yesterday. Let us move to next question now. Question number 15. A force F1 acts on a particle to accelerate it from rest to a velocity v. There is a force F1, it is acting on a particle and it is accelerating it from rest to velocity v of v1, v. The force F1 then is replaced by F2, which retard it to rest. Okay, no? Now, F1 must be equal to F2, F1 may be equal to F2, F1 must be unequal to F2. All these questions they are asking you. Now, if a force is acting on a particle to accelerate it from rest to velocity v. Okay, no? Do you know v equal to u plus at? Right now? They have not told you in how much time. Okay, no? Force F1 is then replaced by F2, which retard it to rest. If I take, okay, no, F1 equal to m into A, and A will be, okay, no, if you are taking in that way, V equal to U plus AT, or you will be taking VA square equal to US square plus 2AS. This part is 0 from rest to velocity V. So you are getting from here A equal to V by T, and from here A equal to VA square by 2S. Now force F1, okay, no, if you take force F1, it is then replaced by F2. So let us take this is A1. Now we are taking F2. Now what F2 is doing? F2 is bringing body to rest. Means retardation is there. It is acting on the body in opposite direction from V to 0. Okay, no? So here your final is 0 and this is V minus AT. From here also you are getting, let us take now it is as A2, this is A1. The A2 will become V by T, or distance if you are taking, then your 0S square equal to VS square minus 2A2S, your A2 will become VS square by 2S. It means A1 is equal to A2. Am I right? If A1 is equal to A2 and mass is also equal, same body you have, so force in magnitude must be equal. Okay, no? Whatever forces are there, F1 and F2, they should be equal in magnitude, but direction will be reversed because both are vector quantity. So we will have to consider direction also. Magnitudes will be equal, but direction will be reversed. F1 may be equal to F2. They have not told you anything about direction. It means that they only want to know from you about magnitude. So your answer will be F1 may be equal to F2. Clear to you? Let us move now to next question. When a constant force is applied to a body, it moves with. If force is constant, again, they are not telling you about the direction. Okay, no? Simply they say you a constant force is acting. Let us assume direction is constant. Constant force means magnitude is also constant and direction is also same. Then it will move with uniform acceleration. Why? M is constant, Newtonian mechanics. You cannot take change in M. So if F is constant, guaranteed acceleration will remain constant. Here answer will be acceleration will remain constant. Let us move to next question. An object will continue accelerating until there is an object and it is continuously accelerating. How? A body will be continuously accelerating when there will be a resultant force going on acting. Let us see what are A, B, C, D. The resultant force on it begins to decrease. No. Its velocity changes direction. The resultant force on it 0. The resultant force is at right angle to its direction of motion. Now, here, first, if you consider resultant force on it begins to decrease, then it will not be accelerating, it may be retarding. Its velocity changes direction. Its velocity changing the direction, okay, no, then guaranteed, now velocity changing direction assuming that magnitude remains constant. In circular motion it is happening, continuously direction is going on changing and a constant force at right angle to direction of motion is acting towards the center. Here its velocity changes direction, resultant force on it is 0 is completely absurd. Resultant force is at right angle to its direction of motion, which is happening in circular motion. The answer for here will be resultant force is at right angle to its direction of motion. Let us move to next question. When an object undergoes acceleration, when any object undergoes acceleration, its speed always increases. Its velocity always increases. 4 alternate they have given you. It always falls towards the earth. Always what they have given you. Okay, no? So we cannot consider that. A force always acts on it. When an object undergoes acceleration, when an object will be undergoing acceleration, guaranteed a force will be acting on the body. When an object undergoes acceleration, its velocity will be going on increasing. So here I think there would be 2 answers. When an object undergoes acceleration, its velocity will be increasing. A force always will be acting on it. But velocity will always, again word is always. Now you take circular motion, their magnitude of velocity is not changing, only direction is changing and force is acting towards the center. If I have to prefer which one in between B and D, then more correct answer will be D, because a force will continuously act on the body. When a force is continuously act on the body, there is possibility that magnitude may not change, direction of motion may be changing. But if a body is undergoing acceleration, guaranteed a force will always be acting on it. So your answer is a force always acts on the body. Now let us move to question number 19. An unbalanced force acts on a body. If any unbalanced force will act on a body, what will happen? The body must remain in the same state? No. According to Newton's first law, body will remain in same state when no net force will act on the body. Must move with uniform velocity. Again Newton's first law, not possible. Must accelerate, must move along a circle. Here, answer will be, it should be accelerating. If an unbalanced force acts on a body, here a small doubt will be there. Will be asking what? What happens to body? A body is wall and you are applying unbalanced force. Will the wall would move? No. It means that body is free to move. Okay, no. And even it is free to move, how much its mass would be? Whether on the surface friction is there or not. So many questions will be there. But in a simple way you have a particle. On the particle, a net force, unbalanced means there is resultant. There is a resultant force acting on the body. So here, benefit of doubt, we will take body must accelerate. Clear to you? Let us move now to next question. For moving a body from rest or stopping a moving body. Now, according to Newton's first law, if you want to move a body from rest or you want to stop a moving body, we need to apply force. Right now, according to Newton's first law, you want to change the initial state of the body. For changing the initial state of the body, you need a net external force which should be impressed on the body. So whatever other answers are there, will not have to think. They are telling you to reduce mass, to wait for some time, to request the body. A body is not a living object, no? So all these are absurd alternate. Your answer is to apply force for moving a body from rest or to stop a moving body. Stop a moving body means you want to change its velocity. You want to make its velocity 0. So you need to apply a net external retarding force. Let us move to next question now. Two objects A and B are thrown upward simultaneously. So I have two objects, okay, no? A and B. You are throwing simultaneously with same speed. The mass of A is greater than mass of B. If I don't consider any other external force, if we consider only acceleration due to gravity, in Newtonian mechanics, you are not considering dimension of the body. Okay? Then they will reach to same height. Okay? But what they say you here, further, let us read. Suppose the air exert a constant and equal force of resistance. If F is retarding force, and it is opposing the direction of motion of the body, and both A and B are experiencing equal force. So whichever will have more mass will have less acceleration. F equal to m into A. If F M, up you are taking A and B. M A, M B, A B. Now, what they say you? Mass of A is greater than mass of B. M A greater than M B. If M A is greater than M B, it means that A B will be greater than AA. Clear? Now what they say you? The two body will reach to the same height. So you are projecting the body A and B with same velocity U from ground Okay, no? So G is acting downward, A is acting downward when body is moving up. They're asking you height. At maximum height, its velocity is 0. So your h will be equal to us square by 2a net. Means us square by 2g plus a. Now you take here, this is h, us square same, 2 same, so h will be proportional to 1 by g plus a. If I take h, a by hb, this will become g plus ab by g plus aa. Understanding? What they say you, AB is greater than AA. AB is greater than AA. The AB is greater than AA, correct? It means that HA will be greater than HB. A will go higher than B. Why? Because in this direction, whatever force is acting, check from here, I am going for AB. AB, MA they have told you, suppose the air exert a constant and equal force of resistance, mass देखा, ठीक है। The word linear momentum was not there. Newton have never used the word momentum. He had always used, momentum. At the place of momentum, he has always told about quantity of motion. Principia de Mathematica, the book written by Newton in English version, whenever you are getting, you check in that. In laws of motion, he has spoken about quantity of motion. Okay, no? So here, quantity of motion Newton had used for linear momentum. Now, let us move to next question. A cannon after firing recoils due to. Already this one I have quoted example when I have taught you Newton's third law of motion. According to Newton's third law, every action has equal but opposite reaction. That when you are firing the cannon, here they are asking you ABCD, conservation of energy, backward thrust of gases, Newton's first law, Newton's third law. Answer directly Newton's third law of motion. Now, let us move to next question. A Diwali rocket is ejecting 0.05 kilogram of gas per second. So they are giving you dm by dt 0.05 kilogram per second and velocity 400 meter per second. The accelerating force on the rocket is, now F equal to d by dt of mv. If you take like this, then it will be dm by dt into v plus m dv by dt. Since we are not considering change in mass, so dm by dt you are taking 0. Due to that, you are taking F equal to m dv by dt and it is equal to ma, right? But if suppose v is constant, if v is constant, then this part will become 0, then your F will be equal to dm by dt into v. Here they are asking you force. F will be equal to dm by dt v. So it will become 0.055 10 to the power minus 2 into 400. 10 to the power minus 2, 10 to the power plus 2 cancelled. Answer 20 Newton. Is it clear to you? So they are asking you what is the accelerating force on the rocket. This is the Pauli rocket. So force is less. Answer is 20 Newton. Let us move to next question now. Okay, the force of action and reaction have magnitude but direction. Newton's third law, so many times you have learned. The force of action and reaction have same magnitude, but directions will be opposite. So magnitude is same, direction is opposite. So same magnitude is same, direction is opposite. Answer B. Clear to you? Let us move now to next question now. Choose the correct statement. They are giving you 4 statements and they are asking you one you choose. Action and reaction forces act on the same body. No, they are acting on 2 different bodies. Action and reaction forces act on different object. Yes, they are acting on different object. A and both are possible. We have already told A is not possible. Neither A nor B is correct. No, B is correct. So answer is action and reaction forces are acting on different object. Let us move now to next question. China and glasswares are packed with soft material when transported, and already you know it is to reduce, increase impulse, reduce impulsive force. Answer will be reduce impulsive force, because impulse is F into del T, and this is equal to change of linear momentum. I have told you yesterday, change of linear momentum, if it is constant, then what will happen? F into del T will remain constant. In F into del T will remain constant, then it will depend upon del T and F, right? If del T is larger, F will be smaller. So, breakage of China or glassware may be minimized. Means you are packing them with soft material when you are transporting only to reduce impulsive force. If you want to write it mathematically, write F del T is dP and it is constant, F proportional to 1 by del T. Clear to you? Soft material will increase time of collision. So, answer here is reduce impulsive force. Let us move now to next question. A force of 50 dyne, it is in CGS system. So, F is 50 dyne. Mass is 5 gram, both CGS, centimeter gram second system, which is at rest. U is 0, time is 3 seconds. Find the impulse. Now, impulse is force into time. Force of 50 dyne is acting on a body of mass 5 gram, which is at rest for an interval of 3 seconds. Here, you have to think that force is acting for 3 seconds. Then find the impulse. If you want, you can convert dyne into Newton. What is dyne, what is Newton? 1 Newton is 1 kilogram into 1 meter by 1 second squared. And what is 1 dyne? 1 dyne is 1 gram 1 centimeter by 1 second squared. They have not told you, but usually will have to give answer in SI. So, you see here, if I convert this, it will be 10 to the power minus 3 kilogram. 1 centimeter minus 2 meter by 1 second squared. Means it is 10 to the power minus 5 kilogram meter per second squared. Newton. So 1 dyne is 10 to the power minus 5 Newton. So this will become 50 into 10 to the power minus 5 Newton. You want to find out impulse. We will be taking force. 1 minute, one thing is more also here. Force of 50 dyne is acting on a body of mass 5 gram, which is at rest for an interval of 3 seconds. So many ways we can get it. We can get change of linear momentum also. By both technique we'll try to see. So if I take f into t, then impulse will be equal to 50 10 to the power minus 5 into 3 Newton second. Right now, I have used f into t. So this one is 150 10 to the power minus 5 Newton second. This will be 1.5 10 to the power minus 3 Newton second. And if you want to find out by change of linear momentum, the final linear momentum will be m into v. I want v. They are telling you a force of 50 dyne is acting on 5 gram. So 50 dyne, I will get acceleration equal to force 50 into 10 to the power minus 5 by mass. Mass is 5 10 to the power minus 3 meter per second square. The 5 will go 10 to the power minus 4, 10 to the power minus 3, 0.1 meter per second square. V equal to AT, 0.1 into 3, 0.3 meter per second. Now m into v, L is change of linear momentum. The initial linear momentum is 0. Final linear momentum is mv. The change of linear momentum will be mv. The mass is your 5 gram, 5 10 to the power minus 3 into 0.3. So how much you got? 1.5 into 10 to the power minus 3 Newton second or kilogram meter per second. So you have both method I have shown you. This is method 1. I have used impulse as force into time, and this is method 2, okay, where I have used impulse as linear impulse as change of linear momentum. Let us move now to next question now. A particle of mass 2 kilogram is moving towards the east with a speed of 5 meter per second. Whenever this type of question is there, first make the direction. This is east, this is north, this is south, this is west. Now what quantities they have given you? M equal to 2 kilogram. It is moving with a speed of 5 meter per second. V is 5 meter per second. If I take it as I vector, this is 5I. It receives an impulse due to which its speed becomes 10 meter per second. The V1, V2 becomes 10 meter per second and continue to move in the same direction, means it is 10I. Find the magnitude and direction of impulse. They want magnitude and direction of impulse. Now, impulse is change of linear momentum. Now, initial linear momentum is mv1, final linear momentum is mv2. So, what will be impulse? Impulse is mv2 minus mv1 because direction is same. So, it will become 2 10 minus 5I. This will become 10I. This much Newton second. Find the magnitude and direction of impulse. You can say 10 Newton second along the direction of east because you have taken I cap along the direction of east. So this is your 10. This is Newton second beta. 10, or you can use kilogram meter per second towards east. Clear to you? This is the answer for number 13. Now, let us move to number 14. A particle of mass 5 kilogram is moving towards the east. Whenever I told you directions they give you east, west, north, south, first take the direction. This is east, this is north, this is south, this is west. Mass 5 kilogram, it is moving towards east with a speed of 10 meter per second. I am taking it I. So V1 10 meter per second. It receives an impulse due to which its speed becomes 2 meter per second and continue to move in the same direction. So its speed has decreased. So my V2 will become 2 meter per second. Find the magnitude and direction of impulse. Again, same you will take, L will be dp, this will become mv2. Check. It is moving with 2 meter per second and continue to move in the same direction. So it is also east, this is also east. mv2 minus mv1. mv2 minus v1. m is 5, v2 is 10i, 2 no. So v2 is, 1 minute, okay, V2 is 2i minus, you have 10i, 2 meter per second towards east, and you have to subtract in that 10 meter per second towards east only. So you are getting 5 into 8 minus I, you are getting 40 Newton second, and direction is minus I. Plus I is towards east. The minus I will be towards west. So your answer is 40 Newton per second towards west. Your answer is 40 Newton second towards west, or 40 kilogram meter per second towards west. Now, let us move to next question. A particle of mass 10 kilogram is moving towards north. Again, you need to consider direction. This one is north, this is east, this is west, this is south. Mass, they have given you 10 kilogram, and it is moving towards north. If you have taken this as I, this one you take as J as unit vector, so it is moving towards north, 20 J. It receives an impulse due to which it now moves towards south. South means minus J. V2 is 5 minus J. Find the magnitude and direction of impulse on the particle. So you will have again impulse mv2 minus mv1, right? Now it is mv2 minus V1. M is 10 kilogram. V2 5 minus J minus V1 20 J. This is minus 5J, that is minus 20J. So this will become 10 into 25 minus J. It is 250 Newton second minus J. Plus J, you have represented north. The minus J will be south. So your answer will be impulse acting on the particle will be 250 Newton second and direction of impulse is towards south. Clear to you? The answer is 250 Newton second or kilogram meter per second and direction of impulse is towards south. Let us move to next question now. A ball of mass 0.5 kilogram moving with, okay, ball mass is 0.5 kilogram moving with velocity 2 meter per second, strikes a wall normally and bounces back. So this is the ball moving in this direction and it is bouncing back. Okay, no? It is bouncing back with the same speed. If the time of contact between the ball and the wall is 1 millisecond, t 10 to the power minus 3 second, then what will be the average force exerted by the wall on the ball? Force is change of linear momentum, rate of change of linear momentum. So first you will have to concentrate on change of linear momentum. So you just check, if this direction I take I, this direction is minus I. The change of linear momentum is P final minus P initial. P final M, V final, V initial, M 0.5, V final. You see they have given you, it is 2 meter per second V initial and V final is also magnitude is 2 meter per second. It is 2 minus I minus 2 I. So you got 0.5 into 4 minus I. So this will become 2, right now? Newton second, okay, no? 5 into 4, 20 and 1 decimal is there. So 2 Newton second, and it is in the direction in which ball had bounced back, means away from the wall. Now we want F. F equal to dp by dt. It is 2 by dt. dt they have given you 10 to the power minus 3. 10 to the power minus 3 second, and this is Newton second. Direction is minus I, because direction of force also you will talk, no. So this will become second cancel. 2000 Newton minus I. What do you mean by that? It means that, okay, the force exerted by wall on the ball is 2000 Newton and direction of this force is away from the wall. Clear to you? Let us move to next question. A certain force exerted for 1.4 second. So time they have given you 1.4 second on a moving body increases its speed from u they have given you 2.8 meter per second, v they have given you 5.6 meter per second. If the same force is later applied for 3 seconds, then the speed of the body is changed by. So you will have to consider a certain force is exerted for 1.4 seconds. Okay, no? On a moving body, increases its speed by this. So your F into 1.4, if I will take direction same, okay, no? The same force is later applied for 3 seconds. So this will be m v minus u, 5.6 minus 2.8. Okay, no? So this will become m 0.8, 2.8, f 1.4, 2 times f equal to 2m. Okay, we have kept f as 2m. Now they say you same force is later applied for 3 seconds, then what is the change of speed? Up now you are applying f into t. This will be equal to the speed of the body changes by. The speed of the body changes by m, I'll put as del v. This quantity is nothing but change of velocity, na? So this will become f, yeah, 2m t. Now they have given you 3 seconds. This will be equal to m del v. M is cancelled. So del v will become 6 meter per second. The speed of the body will be changed by 6 meter per second. Check, they are telling you change. They are not asking you final speed. The speed of the body changes by. If they will ask what will be my final speed, then at this place I will take mv minus 2.8. Is it clear to you? Then if they are asking me v, then I will be taking this as f as 2m into 3 as mv minus 2.8. m I will cancel. V will become 6 plus 2.8, 8.8 meter per second. But because they have asked you change of speed, so your answer will be 6 meter per second. Let us move to, now no question. This one is fully completed. Okay, no? So complete classwork for day 13 also is over. Tomorrow I will be starting what is some topics we'll be learning. Normal reaction, free body diagram, very, very important. If you understand free body diagram, you will be capable to solve problems related to friction, work power energy, even in Newton's laws of motion. All typical problems will be capable to solve. Pulley-based problem, tension-based problem, all the problems will be based on free body diagram. So first I will teach you that part, and then we'll be going for, okay, classwork and homework. Time is over. Already 5 minutes extra it is. Okay, thank you to all of you. Have a nice day.
Good morning, students. So yesterday we have discussed sets and different types of set, power set, subset, and number of subsets, right? So I've given you homework based on that. So today we'll be doing questions on that only, and then we'll be learning operations on sets, right? So let's start. First question, let A equal to 1, 2, 3, 4, 5. Which of the following is false, right? Which of the following is false, right? So what they are saying, 3, 4 is a subset of A. That is not correct, right? 3, 4 is an element of A, right? It is an element of A, which is not correct, right? What are they saying? 3, 4 belongs to A. This is true, right? This is true because this is an element which belongs to A, right? Now, a set which contains 3, 4 is a subset of A. This is also true, right? and 1 comma 2 comma 5 is also a subset of A. This is also true. So the correct answer for this, because they are asking which of them is false, right? Which of them is false is going to be option A. All right. I hope this is clear to everyone. Next, the number of subsets of A equal to 0, 1, 2 will be equal to what, right? How many elements are there in A, right? How many elements are there in A? If you see, n of A is equal to 3, right? N of A is equal to what? 3. If n of A is 3, number of subsets, right? Number of subsets will be equal to what? 2 to the power n, which will be equal to 2 to the power 3, which will be equal to 8. Right? So the answer for this will be how much? C. Right? The answer for this will be how much? 3. 2 to the power 3, right? So it is 8. Alright? Which of the following is correct? Which of the following is correct? Now, A is a subset of B, right? B is a subset of A, U is a subset of A and B, and none of the above. Now we are going to learn about Venn diagram, but I think all of you have learned about Venn diagram in 8th and 9th standard, right? So we know that, just I gave an example, A is actually like a Hyderabad, right? B is like Telangana, right? And U is like India, right? So A is completely inside what? B. That is why I will say that A is a subset of B, right? The answer is what? A is a subset of B. As I have given an example yesterday also, that Hyderabad is a subset of Telangana, right? So that is what the example is, right? So this B is a subset of A is wrong. B is a superset of A, and U is a superset of A and B, right? This is also wrong. None of the above, right? Okay, next. Fourth. If A equal to 1, 3 and 4 and B is equal to X such that X belongs to R and X square minus 7X plus 12 equal to 0, then which of the following is true? Which of the following is true? So let's solve B first, right? Let's solve B first. If I solve, I'll get X square minus 7X plus 12 equal to 0. It means that X is equal to 3 and X is equal to 4, right? It means that X equal to 3 and X equal to 4. Now, they both are real number, so both of them will be coming inside B. B will be what? 3, 4, right? Okay, now A is a subset of B. A is a subset of B. That is incorrect, because B is actually a subset of A, right? B contains in what? A. So B is going to be what? Subset of A, right? The answer for this will be what? B is subset of A. A is equal to B is not correct. A is equal to B is not correct. And A is not even a subset of B, right? A is equivalent to B, that is also incorrect. Why? Because for equivalent, we check that N of A is equal to N of B or not, right? In this case, N of A is 3 and N of B is what? 2. So this is not equal, right? So that's why option D is also incorrect. Option D is also incorrect, alright? I hope this is clear to everyone. Fifth question. Consider the following statement. The null set is a subset of every set. Null set is a subset of every set. That is a correct statement, right? I have told you yesterday only, null set is a subset of every set, and any set is also a subset of itself, right? That is why this first statement is going to be correct, right? Okay. They are asking the correct one, right? So let's see. This option is already rejected because 2 and 3, it doesn't contain 1, right? Second statement, every set is a subset of itself. As I have just mentioned that every set is also a subset of itself, this is also correct, right? Now let's read the third one, right? This is also incorrect because it doesn't have 2. Now third one, if a set has 10 elements, then its power set will have 1024 element. That is also correct, right? This all three statements are what? Correct. Why? Because in power set, number of elements in power set is equal to what? Total number of subset, which will be equal to what? 2 to the power 10, right? Which will be equal to what? 2 to the power 10, and that is nothing but 1024, right? That is nothing but 1024. So that is why all the three statements are correct here. So the answer will be what? 1, 2 and 3, right? The answer will be 1, 2 and 3. Okay, I hope this is clear to everyone. Let's go to the next question. Question number 6. If A is equal to minus 3, x is between minus 3 to 3 and x belongs to integer, right? As I have told, z actually means what? Integer. X belongs to z means what? Integer. So they are saying A is an integer between minus 3 to 3. And the number of subsets of A is equal to what? Right? So first we need to find out how many integers are there between minus 3 to 3. Correct? So let's find out. A will be equal to what? Minus 2, minus 1, 0, 1 and 2, right? Minus 2, minus 1, 0, 1 and 2, right? These are the integers between minus 3 to 3. Am I correct? A is equal to minus 2, minus 1, 0, 1 and 2. So how many elements are there in this? 5, right? If I see number of elements in A is how much? 5. If number of elements in A is 5, so can I say number of subsets of A will be equal to what? 2 to the power n, right? Will be equal to what? 2 to the power n, which will be equivalent to nothing but 2 to the power 5, which will be equal to what? 32, right? Which will be equal to what? 32. So the correct answer will for this will be what? Equal to 32, right? If they ask you number of non-empty set, number of non-empty subset, number of non-empty subsets of A, it will be equivalent to how much? 2 to the power 5 minus 1, which will be how much? 31, right? So that will be how much? C. Understood? I hope this is clear to everyone. All of this question is clear to everyone. It's for simple. Just we need to find out how many integers are there between minus 3 and 3. So it is minus 2, minus 1, 0, 1 and 2. Okay. I hope it is clear. Let's go to the next question. Question number 7. Which of the following is true? Which of the following is true? Right now, actually you don't know about open bracket and square bracket. So you can either skip this question or I'll explain you what is the meaning of this open bracket and square bracket, and then you can guess what is the meaning of this. Okay. So I'll explain you what is the meaning of this. Okay. Give me a minute. Okay. So now we have seen set, and we know there are two types of representation of set. One is roster method, one is set builder method, right? But there are two types of sets also. Okay. One is continuous set, and second is discrete set. Second is what? Discrete set. So in discrete set, how do we write? We write in this way. Right? We write in this particular method, right? In continuous set, continuous name itself is saying that it is going to be continuous. From one number it will be starting and it will be going till end of that another number. Alright. So for continuous set, the representation is in terms of this type of bracket. This is known as square bracket, and this type of bracket which is known as round or open bracket, right? This is known as round or open bracket, and this is known as square, right, or closed bracket. Square or closed bracket. Okay. Now what is the meaning of this? We'll understand, right? And but just first we have to understand that it is a continuous set and this is a discrete set. What do you mean by discrete? We write all the numbers present inside the sets in this particular set, right? All the numbers, right? So it will be A, B, C, D, E. If we write A, B, C, D, E, it means we are writing all the numbers with A, B, C, D, E. Only those numbers are there. So we can actually count, right? So we can actually count the number of elements in discrete set, right? But if I am writing in continuous set, so this is, let's say, A, this is B, and this is A and B. Now what is the meaning of this? Let's understand between closed bracket and square bracket. Okay, so I'll take an example. Let's say if I take square bracket 2 to 3, if I write square bracket 2 to 3. Okay, so what is the meaning of this? I will draw a number line. Okay, I will draw a number line. Right, a number line. In this number line, we know that, let's say it is 0, this is 1, this is 2, and this is what? 3. Okay, 0, 1, 2 and 3. So in terms of square bracket means what? All the numbers between 2 and 3 are coming. All the numbers between 2 and 3 are coming. Means this all the numbers. How many numbers are there? There are infinite numbers. Yesterday only I told you that between any two real numbers there are infinite real numbers, right? So how many are there? We can't count. Right? For example, 2.1, 2.111, 2.112, like that, there could be infinite real numbers between what? 2 and 3, and we can't count it, right? So to include all those numbers, we are writing in terms of what? Square bracket, right? Now what is so specialty about square bracket? That all the numbers between 2 and 3 are coming, and also the numbers 2 and 3. So if the numbers are coming, I will put this kind of dark ball, right? Dark ball or black ball. What does this include? This include that these numbers, the end numbers, boundary numbers, which is 2 and 3 in this case, are also included in this set, right? Are also included in this set. So in square bracket, what does it mean, right? If I write square bracket A to B, what does it mean? All the numbers between A and B are included, okay, along with A and B, right? So A and B will also be included in this numbers, right? Along with A and B. Am I clear? That's why we have placed a dark ball in this, right? Now what is the difference between round or open bracket? So I'll again draw the same number line to explain you. Okay. Right? 0, 1, 2 and 3, right? Now I want to represent what? I want to represent just 2, 3 open bracket, right? 2, 3 open bracket. So what I will do? For that, what I will do? All the numbers between 2 and 3 will be coming. All the numbers between 2 and 3 will be coming, but not 2 and 3 themselves, right? But not 2 and 3 themselves. Okay? Just give me a minute. Yes. So all the numbers between 2 and 3 will be coming, but not 2 and 3 themselves, right? So these boundary numbers are not coming. That's why I have placed this kind of white ball or a hollow ball, right? So we'll say hollow or white ball, right? Here what does it mean? Dark or black ball. Right? What does this mean? This means that the number is included, and this means the numbers are not included, right? So open bracket A to B means all the numbers between A and B are included, right? But not A and B themselves, right? A and B will not be included in this case. Okay, I hope this is clear to everyone. Right? The boundary value will not be included in this case. Okay, now please mind it that square bracket and open bracket can appear in pair. What I mean by that? That the possibility, this can also be written. This can also be a possibility, and this can also be a possibility, right? This can also be a possibility. What does the first thing represent? First thing represent all the numbers between A and B are included. A and B are included, right? Along with A, right? Why A? Because at A there is a square bracket, right? So A will be included, but not B, right? But not B. Why? Because at B there is a open bracket. right? Okay, what about the next one? Next one means all the numbers between A and B are included along with B, this time along with B, but not A, right? Why not A? Because at A there is a open bracket, right? So A will not be coming, but apart from A, all the numbers between A and B along with B will be included in this particular set. Okay, I hope this is clear now. Now let's go back to the same question and understand that what it is trying to say. Okay, all right. So which of the following is true, right? What are they saying? Which of the following is true? Okay, so now let's do this question. So 3 comma 7 square bracket 3 comma 7 is a subset of 2 comma 10, right? So what I will do, I will draw a number line for this question. I will draw a number line to make you understand. So see, I will draw a number line, right? Let's mark 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, right? So the first set, what they are saying is which set? First set they are saying 3 comma 7, right? 3 comma 7. So at 3 there will be a dark ball, 7 also will be a dark ball. Why dark ball? Because there is a square bracket at this, right? 3 comma 7 and this will be like this, right? 3 comma 7 and this will be like this. So all the numbers are coming between them. So I will shade this region, right? Am I clear? Okay. And the other set will be which one? 2 comma 10. So at 2, since there is a round bracket here, so I will mark a white ball or hollow ball, and 10 also there is a hollow ball. So if I join them, right, this will be the set. Right, this will be a set. So if this is a set, can I say the yellow part is a subset of the blue part? Right. So the first statement what they are saying is true. Right. First statement is true. Right. Second statement will not be true because the numbers from 0 to 4 is not the part of this. This is a wrong statement. Right. Third statement what they are saying 5 comma 7. In this 7 is there. In this 7 is not there, and 5 is there. Right. So that's why this is wrong statement, right? Okay, then last 2 to 7, right? 2 to 7. Now 2 to 7 is a subset of this. Now the numbers from 2 to 2.9, right, are not there in the superset. That's why it is not a true statement, right? It is not a true statement. I hope this is clear to everyone. The correct answer for this is what? Option A only, right? Option A. Okay. I hope everybody understand now what is a square bracket, what is a open bracket, and this was required for solving this question. Okay, let's go to the next one. The number of subsets of the power set of A. Number of subsets of the power set of A, 7, 10, 11. Okay, so in this case, how many elements are there in A? 3. Right, how many elements are there in A? 3. And number of elements in power set of A will be how much? 2 to the power 3, which will be how much? 8. Right. Now what they are saying, number of subsets of this particular power set. Number of subset. So total number of subset will be how much? Total number of subsets will be 2 to the power 8, which is how much? 256. Right, which will be how much? 256. So the answer for this will be how much? D. Right? The answer for this will be how much? D. Okay. I hope this is clear to everyone. Lot of people must have confused between 2 to the power 3. Right? But this is not in the option only. So there is no doubt. There should be no doubt about this question. Okay. Let's go to the next one. Set A has m elements and set B has n elements. Right? If the total number of subsets of A is 1, 1, 2 more than total number of subsets of B, then the value of m comma n is what? Okay. Now, number of elements in set A is equal to how much? M. Right? Number of elements in set A is equal to how much? M. And number of elements in set B is equal to how much? N. Right? So, total number of subset total number of subsets of A will be how much? 2 to the power m, right? Will be how much? 2 to the power m, and total number of subsets of B will be how much? 2 to the power n, right? Will be how much? 2 to the power n, right? Now, what are they saying? They are saying that total number of subset of A is more, right? So A is big and B is small. So I have to add in B, right? I have to add in B. This is A, this is B. I have to, how much it is more? 1, 1, 2, right? So can I say, what they are trying to say is 2 to the power m, right? 2 to the power m is equal to 1, 1, 2 plus 2 to the power n, right? Is equal to 1, 1, 2 to the power n. Am I clear? Now we need to see which two powers of A, right, which two powers of 2 has a difference of 1, 1, 2, right? Which two powers of 2 has a difference of 1, 1, 2, right? So the answer will be 2 to the power 7, which is 128, and 2 to the power 4, which is 16, right? Which is how much? 16. If I differentiate them, if I take a difference, I'll get 1, 1, 2, right? I'll take a difference and I'll get 1, 1, 2. So it means what? That m should be equal to 7 and n should be equal to what? 4, right? That's the only possibility. M should be equal to 7 and n should be equal to what? 4. And what are they asking? The value of m into n, right? They are asking the value of m into n. So m into n will be how much? 7 into 4, which is 28, right? So the answer will be what? B. Answer will be B, 28. Okay. I hope this is clear to everyone, right? 9th. 10th question. The total number of elements in the power set of A containing 20 elements. Containing 20 elements is equal to how much, right? So total number of elements in the power set of A. So number of elements in power set of A is equal to 2 to the power n, right? It is equal to what? 2 to the power n. And n is how much? N is 20, right? N is 20. So I can just plug in the value and get 2 to the power 20. So the answer will be what? A, right? The answer for this will be how much? A. Okay. I hope this is clear to everyone. 10th question. Next. 11th. If A is equal to 1, A, 3, then the power set of A is equal to what, right? In the power set, there will be a null set, right? Then there will be a 1, right? Single elements, 1, A, 3, right? Then there will be a double elements, 1, comma A, comma 3, and 1, comma 3, right? And at last, there will be 1, comma A, comma 3, which will be all of them, right? Which will be all of them, right? Which is nothing but A. This can be written as what? A. So which is the set which will contains all the 3, right? If you see, I think the first option, right? First option is the set, because this will not have some elements. So answer is A. C and B is not the right answer, right? C and B are not the right answer. The correct answer for this is how much? Option A. Okay. I hope it is clear to everyone. 11th question. Next. If A is equal to lambda, comma mu, right? It's a set, it's itself a set, and the power set of A is equal to what, right? Now, first identify how many elements are there in set A, right? First identify how many elements are there in set A. There are 1 and this is 2, right? How many are there? 2 elements. If there are 2 elements in set A, right? So number of elements in power set of A will be equal to 4, because 2 to the power 2, right? The first one will be what? First one will be 5, right? 5, right? Null set. Then second one will be single element, which is lambda, right? Single element, which is lambda, correct? Then third will be single element, this set, this is an element, right? So this will be lambda, comma mu, right? And the next one will be this complete set itself, right? This set itself, which will be lambda, comma mu, right? Lambda, comma mu. Okay. So which is the set which contains all of this? right? I think the correct answer is what? Option C, right? This is incorrect and this is incorrect because it's a set containing lambda comma mu, right? There can be a confusion between this one and this one, and I hope it is clear why it is not the answer, right? This one doesn't have phi, that's why this is also not the answer. So the correct answer for this is how much? Option C. Okay, I hope this is clear to everyone. I guess that's the end. Yes, that's the end. Now we'll be starting the next thing, which is what? Operation on set, right? Next topic for today, which is what? Operations on sets. Right, this is a very important topic. Just give me a minute, we'll start it. Okay, operations on sets, right? So what does operations on set means? First, there is something as union of two sets. Union of two sets, right? Union of two sets. So let there be two sets A and B, right? Let there be two sets A and B. Okay, and we want to find the union. Okay, now first of all, how does union is represented? So union is represented with what? A union B, right? How do we write it as? A union B, right? We represent it with capital letter U, kind of U, right? It's A union B. Now what does union mean? Union means, right? Union means what? All the elements present in either A or B, all the elements present in either A or B, or both A and B, or both A and B. Okay, all the elements are present in A and B, or both A and B. So for example, for this is what? Let's say, one example for this is, let's say A is what? 1, 2, 3, right? And B is what? 2, 3, 4, 5, right? 2, 3, 4, 5. And what do I need to find out? I need to find out union, right? I need to find out union. So A union B I need to find out, right? So A union B will be what? 1 is there in A, so it will be coming, right? 2 is present in both of them, so it will be counted as 1, right? 3 is also present in both of them, so it will be coming, right? And 4 and 5 are present in what? B. That's why this will also be coming, 4 and 5, right? So this is what the meaning of A union B, right? I hope it is clear. All the element present in either A or B, or both A and B, both will be coming. All right. So A or B, or both A and B. All right. I hope this is clear to everyone. The meaning of union, right? Now we understand the same thing through Venn diagram. Right? I will explain this through also with Venn diagram. Right? Venn diagram. Okay. So Venn diagram I'll explain it later also. Okay, for tomorrow. But I'll just explain what is the meaning of Venn diagram. So let's say there is a set, okay, S, and in this there is a set A, right? And there is a set B. Okay, so A union B, right? A union B will be actually what? This part. This is just A, right? This part will also be coming, right? And this part is just B, right? So in A union B, all these three parts will be coming, right? All these three parts will be coming. This is the meaning of what? A union B. Okay. I hope it is clear from Venn diagram what is the meaning of A union B, right? So for in our example, I have taken I have taken A to be what? 1, 2 and 3, and B to be what? 2, 3, 4 and 5, right? So if I want to write this inside this particular set, 1 will be coming in just A, 2 and 3 will be coming in what? In both of them, right? And 4 and 5. 4 and 5 will be coming in what? Both A and B, right? 4 and 5 will be coming in what? Both A and B. So sorry, 4 and 5 will be coming in just B. Understood? So this is how we represent the Venn diagram A union B. Alright? I hope this is clear to everyone. What is the meaning of A union B? Okay. Now, next. Next, if I want to write down is intersection, right? Intersection. Intersection of two sets A and B. Okay. Now, what does intersection? How does we represent intersection? First of all, intersection is represented by this way, right? A intersection B, right? How do we represent intersection? A intersection B. All right. Union is U, and this is like reverse of U. All right. Now, what does A intersection B means? Elements which are present in both A and B. Elements which are present in both A and B, right? So if I want to explain it through Venn diagram, right? If I want to explain it through Venn diagram, let's say this is set A, right? And this is set B, right? This is set B. So A intersection B will be what? This particular set, right? A intersection B will be what? This particular set, which is common in between A and B, right? This is common in between A and B. And like for our example, if I see from our example side, right? Let's say A was how much? A was 1, 2 and 3, right? B was how much? B was 2, 3, 4 and 5, right? So A intersection B will be how much? A intersection B will be how much? 2, 3, right? 2, just 2 and 3. So this will be 2 and this will be what? 3. So this is A intersection B. Alright. I hope this is clear to everyone. What is the meaning of intersection? A intersection B is what? A union B is what? Right. This is very important. This will be used in solving the questions. Right. While solving the question, this will be used. Okay. Okay. Let's do the next point. Now the next part is what? Okay. Disjoint sets. Disjoint sets. Disjoint sets, right? Now what does disjoint sets mean? Right? Disjoint sets means that if there is nothing common between A and B, right? If there is nothing common between A and B, then we say that A and B are disjoint set. Then we say A and B are disjoint sets. Right? What does actually it means? That is A intersection B is equal to 5. Right? A intersection B is equal to what? 5. For example, there is nothing common in them. Right? So if I want to explain through Venn diagram, right? This is A and this is B. Right? So it is U. Understood? There is nothing common. There is no common area between A and B. So we say then A and B are what? Disjoint sets. Okay. I hope this is clear. And in terms of set, we say that A intersection B is equal to 5. Right? A intersection B is equal to what? 5. Alright. I hope this is clear to everyone. Right. For example, for this is what? Let's say A is equal to set of odd numbers when throwing a die. Right, and B is what? Set of even number while throwing a die. right? Set of odd numbers and set of even numbers, right? So they don't have anything common between them. So we'll say that in this case A intersection B will be equal to what? 5. A intersection B will be equal to what? 5. Alright, I hope it is clear what is the meaning of what? Disjoint sets. Then next, difference of sets. Difference of sets. Difference of sets, right? So what is the meaning of difference set? It is represented by A minus B or B minus A, right? A minus B or B minus A. Now both of their meanings are different. A minus B and B minus A are different. So I'll explain you one by one what is the meaning of A minus B and B minus A. So if I just want to write down A minus B, right? So A minus B means what? Elements which are present only in A and not in B. Elements which are present only in A and not in B, right? Similarly, what will be B minus A? B minus A, elements which are present only in B and not in A, right? Elements are present only in B and not in A. So for example, right? If suppose I have said that A is equal to what? 1, 2, 3 and B is equal to what? 2, 3, 4, 5, right? A is equal to 1, 2, 3 and B is equal to 2, 3, 4, 5, right? Then what is the value of A minus B and B minus A? So A minus B will be what? See, 2 and 3 are in both of them, right? So I just want an element which is present only in A and not in B. So I will just say it is 2, right? And B minus A will be equal to what? B minus A only in B. So it will be what? 4, 5. Right? It will be what? 4, 5. Okay. So I hope it is clear to everyone what is the meaning of A minus B and B minus A. And according to Venn diagram, if I want to explain through Venn diagram, right? So this was, let this be A, right? Let this be what? B. Okay. So this part will be what? A minus B. Right? This is what? A minus B. And this part, right? This part will be what? B minus A. Right? A minus B and B minus A. Alright? I hope it is clear. There is nothing common in between them and we have to subtract the intersection part. Whatever was common in both of them, we have to remove it to find A minus B or B minus A. Okay? Next. Next point is symmetric difference. Right? Next point is what? Symmetric difference. Next point is what? Symmetric difference of two sets. Right? Symmetric difference of two sets. Now, this is represented by A delta B. Right? A delta B. Okay, and what does it mean? A delta B. What is the meaning of symmetric difference? It is equal to, this will be equal to what? A minus B union B minus A, right? A minus B union B minus A. And actually what does it mean? A elements which are present only in A or only in B. right? Elements which are present only in A or only in B. That is the meaning of what? Symmetric difference, right? So, for example, if I have given A is equal to 1, 2 and 3 and B is equal to 2, 3, 4, 5. Right? A is equal to 1, 2, 3 and B is equal to 2, 3, 4, 5. So what will be the symmetric difference A and B? Right? So in this only 1 will be coming, 2 and 3 is common, right? So that will not be coming. So 1, 4 and 5 is actually what? Symmetric difference. 1, 4 and 5 because 1 is present only in A and 4 and 5 are present only in B. So that is why that is the answer. Okay, I hope this is clear to everyone. Now we'll understand the same thing to Venn diagram, right? Same thing to Venn diagram. So if I want to understand the Venn diagram, let this be A, right? Let this be what? B, right? Let this be A and let this be B. So what will be the symmetric difference? Symmetric difference will be this part, right? This is A minus B or B minus A, right? This middle part will not be coming. A intersection B will not be coming in this case. Alright? I hope this is clear to everyone. What is the meaning of symmetric difference of two sets A delta B? Okay, now let's go to the next part. Next part, complement of a set. Okay. Next part is what? Complement of a set. Right. First of all, how do we represent this? Right. We represent the complement. We represent the complement by either A complement, A bar, or A dash. Right, there are three ways of representing a complement: A complement, A bar or A dash. Right, all of them means the same thing: A bar, A complement, A dash. Right, and what is the meaning of this? Right, A bar elements which are not present in A, which are not present in A, right, which are not present in A. For example, so we can say that A complement is equal to U minus A. What is U? U is the universal set, right? Everything but A. Everything but A means what? A complement. So if I want to write, if I want to represent, let this be what? A. Okay. So A complement, this is U. So A complement will be this. Right? A complement will be what? This. This is the meaning of A complement. Everything but A. Alright? So these are what? Operations on sets. These are the meaning of this. So for example, let's say U is equal to what? 1, 2, 3, 4, 5, 6. Right? And A is what? 1, 2, 3. B is what? 2, 3, 4, 5. Right? And if I want to find out A complement, what will be A complement? A complement will be what? 1, 2, 3. Everything but 1, 2, 3 in the universal set. So what will be remaining? 4, 5 and 6. Right? What will be remaining? 4, 5 and 6. And what will be B complement? B complement will be what? Everything but 2, 3, 4, 5. So it will means 1, 6. Right? 1, 6. Alright. So I hope this is also clear what is the meaning of complement. Right? Now we'll do one example based on this and then we'll be giving you homework and the other questions. Okay. I hope all of this are clear to everyone. Okay. Right? Let's do an example. Let U is equal to, right? Let U is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. And they have given A is equal to 1, 2, 3, 4, right? B is equal to 2, 4, 6, 8, and C is equal to 3, 4, 5, 6, right? 3, 4, 5, 6, right? Now what do we need to find? Right? Let's first find out is what? First they are asking us to find A complement, right? A complement, B complement and C complement, right? So let's find out A complement, B complement and C complement. So what will be A complement? Everything but A, right? So 1, 2, 3, 4 is mentioned, so it will be what? 5, 6, 7, 8 and 9, right? 5, 6, 7, 8 and 9. Then B complement will be equal to what? B complement 2, 4, 6, 8, right? So 2, 4, 6, 8 we have to remove. So what will be left? 1, 3, 5, 7, 9. All the odd numbers, correct? Now what will be C complement? C complement will be 3, 4, 5, 6 we have to remove, right? So 1, 2, 7, 8 and 9. Right, 1, 2, 7, 8 and 9. So this is what? A complement, B complement and C complement. Now let's find out the next thing. Next thing they are asking us to find, right? Let's say we need to find A union B, right? Let's say we need to find what? A union B, right? What will be A union B? A union B will be equal to what? 1, 2, 3, 4, 6 and 8, right? A union B will be equal to what? 1, 2, 3, 4, 6, 8, correct? Now, what will be B union C? B union C, right? We need to find out B union C. So, B union C will be how much? 2, 4, 6, 8 and 3, 4, 5, 6. So, 2, 3, 4, 5, 6 and 8. Right? 2, 3, 4, 5, 6 and 8. Then last A union C, right? A union C. For A union C, what I'll do? This one and this one, right? So what I'll do for this? I'll write 1, 2, 3, 4, 5 and 6. Right? 1, 2, 3, 4, 5 and 6. Alright? I hope all of this is clear to everyone. Right? What is the meaning of this and this? Okay. Let me see if I can just select it. Okay. So next again the same question I am doing. I am writing it. I am writing the same question again, that let U is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, right? A is equal to 1, 2, 3, 4. B is equal to 1. Sorry, B is 2, 4, 5, 6. 2, 4, 6, 8 and C is equal to 3, 4, 5, 6. 3, 4, 5 and 6. Right. So we already found A union B, B union C and C union A. Right. Now I need to find out, let's say, I need to find out A union B complement. Right, A union B complement. Okay, so what I'll do now? A union B complement. First, I'll find out A union B, right, which we already did, I think, in the last slide. Right, yes, there is A union B. It is how much? 1, 2, 3, 4, 6, 8, right? And if I want to find out A union B complement, so from U, from U, I will remove everything 1, 2, 3, 4, 5, 1, 2, 3, 4, 6, 8, right? So what will be coming? 5, 7 and 9, right? 5, 7 and 9, correct? Now, if I want to find out B union C complement, B union C complement, so what will be coming? 1, right? 2, 3, 4, 5, 6, 7 and 9, right? And let's say if I want to find out A union C complement, A union C complement, right? A union C. So what will be coming? A union C, right? So you will be having, here is A union C, 1, 2, 3, 4, 6, right? So what you will be doing? You will be writing the 7, 8 and 9, right? 7, 8 and 9. Understood? Okay, I hope this is clear to everyone. Now in this question, let's say instead of finding A union B intersection C, they are asking us to find A intersection B complement, right? A intersection B complement, B intersection C complement, right? And C intersection A complement. Okay, C intersection A complement, right? So how will I do this question? First, I need to find out what is A intersection B. Then only we can find out the complement of it, right? So what I'll do? What is A intersection B? That we need to find out. A intersection B will be, is there anything common between A and B? Right? So see that 2 and 4 are common, right? 2 and 4. So we can say 2 comma 4. Right? So I can say A intersection B complement. Right? A intersection B complement will be what? 1 comma 3 comma 5 comma 6, 7, 8 and 9. Right? 1 comma 3 comma 5 comma 6 comma 7 comma 8 comma 9, right? Then same logically you need to find out B intersection C, right? What is B intersection C? Is there anything common between B and C? I think 4 and 6, right? 4 and 6. So I can say B intersection C complement, right? B intersection C complement will be equal to what? 1, 2, 3, 5, 7, 8 and 9, right? 1, 2, 3, 5, 7, 8 and 9, right? Then last C intersection A complement, right? So I'll find out C intersection A first. Is there anything common between C and A? Right? There is common. What is common? 3 comma 4. Right? 3 comma 4. So C intersection A complement will be equal to what? 1, 2, 5, 6, 7, 8 and 9. Right? 1, 2, 5, 6, 7, 8 and 9. Okay. Now, again I am taking the same question so that it is clear for everyone. U equal to 1, 2, 3, 4, 5, 6, 7, 8 and 9. Right, so this is U, and what do we need to find out? Yes, we need to find out A is, they have given A to be what? 1, 2, 3, 4. B they have given us 2, 4, 6, 8, and C they have given us 3, 4, 5, 6, right? 3, 4, 5, 6. So I need to find out what is A minus B, right? Complement. Then B minus C complement, right? And C minus A complement, right? A minus B complement. Let's say we further take it. We also need to find out B minus C complement, right? And just a minute, I'll take some space. C minus B complement, and here what? C minus A complement, and let's say last A minus C complement, right? So A minus B complement. First about A minus B. So first we need to find out A minus B. What will be A minus B? A minus B, right? What is the elements are present only in A, right, and not in B. So 2 and 4 was common in them. So I can say it is just 1 comma 3, right? It is what? 1 comma 3, right? Now we need to find the complement. We need to find the complement. So for complement, what will I do? A minus B complement will be everything in universal set but 1 and 3, right? So it will be how much? 1 and 3 will remove, right? So I will get how much? I'll get 2, 4, 6, 5, 6, right? 2, 4, 5, 6, 7, 8 and 9. Right? This will be A minus B complement. Now, similarly, I need to find out first B minus C. B minus C will be what? B minus C. Everything but not anything common between them. So it will be what? 2 and 8. Right? It will be what? 2 and 8. So its complement, B minus C complement will be equal to what? 1, 3, 4, 5, 6, 7, 9. Right? 1, 3, 4, 5, 6, 7 and 9. Then B minus C. Same thing will do for B minus C. I think this I have already done. Here we'll do B minus A. Right? Here we'll do B minus A. Okay. I wanted to find B minus A. So what will be B minus A complement? Right? So for B minus A complement, I first need to find out B minus A. Right? B minus A. What will be B minus A? Again, 2 and 4 are common between A and B. So I have to remove that. What will be left? 6 comma 8. Right? 6 comma 8. So B minus A complement, right? B minus A complement will be how much? 1, 2, 3, 4, 5, 6 will not be coming, 7 and 9. Right? This will be what? B minus A complement. Right? Same logically, I want to find out C minus B. So C minus B will be equal to what? Everything in C but not be in B. Right? So 4 and 6. 4 and 6 are common in both of them. So in C only what is there? 3 and 5. Right? So I'll be getting 3 comma 5. So its complement will be equal to what? Its complement will be 1, 2, 4, right? 6, 7, 8 and 9. Right? Last two are remaining. Now C minus A complement A minus C. So C minus A. What will be C minus A? Right? C minus A. C minus A will be everything in C but not in B. A. Right? Everything in C but not in A. So what is common in A and C? I think 3 and 4. Right? So in C minus A there will be 5 comma 6. Right? 5 comma 6. So C minus A complement will be 1, 2, 3, 4, 7, 8, 9. Right? 1, 2, 3, 4, 7, 8 and 9. Next, last, A minus C complement. So for A minus C complement, I will find out A minus C. Right? A minus C. What is A minus C? Right? Again, 3 and 4 are common. 3 and 4 are common. So only 1 and 2 will be coming. Right? 1 and 2. And its complement will be how much? A minus C complement, right, will be equal to what? It will be equivalent to 3, 4, 5, 6, 7, 8 and 9, right? 3, 4, 5, 6, 7, 8 and 9, right? So this is all about the operations on set. I hope everyone understood what is the meaning of union, what is the meaning of intersection, what is the meaning of disjoint set, right? What is the meaning of A minus B, B minus A, difference of two sets, right? Then what is the meaning of symmetric difference, right? And what is the meaning of last complement, right? So I'll revise it and then I'll give you the homework. Acha. Yes. So union of two sets. What is the meaning of unions? All the elements present in either A or B, and both A and B. All these three things will be coming in A union B. Right? Then next, this is through the Venn diagram we have understood what is the meaning of A union B. Then next, intersection. Intersection means elements which are present in both A and B, right? In both A and B. So this particular part is what? A intersection B. Next, disjoint set. Disjoint set means what? There is nothing common between them, right? There is nothing common between them. So A intersection B will be equal to what? 5 for disjoint sets, right? Difference of sets. Difference I have already explained. Elements which are present only in A and not in B. B minus A will be what? Elements which are present only in B and not in A, right? So this, according to Venn diagram, this will be A minus B and this will be B minus A, right? Next, complement of a set. What is the meaning of complement? Elements which are not present in A, right? Elements which are not present in A, right? Everything but A. So it's the outside area, right? U minus A. Then we have seen the example, right? And this is all about today's class. Okay, so I'll give you the homework now. I think we have completed already till day 13, right? So I will give you homework of, I guess, 14 we have done, right? 14 till 14 we have done, yes. So I'll give you an example of 15, right? Yes. So today's homework is what? Worksheet. Today's homework, worksheet number 15, right? Page number 76. Page number 76, it is the homework for today. Okay, all 12 questions. All 12 questions. We'll be discussing it tomorrow, right? Just like regular thing. And then we'll be doing the next topic, which will be what? Venn diagram. Okay. I hope it is clear for everyone, right? Thank you very much. We'll see you tomorrow.